A very good afternoon, students. In this chapter I am going to start the ionic radii. So what is the meaning of it? The effective distance from the nucleus of the ion up to which it has an influence in ionic bond. Means is this, what is the distance which you have taken from the nucleus till the ionic bond, that is said to be the ionic radii. In this one, two things are important. The radius of positive ion is always smaller than that of the parent atom. The radius of negative ion is larger than that of the parent atom. These two things will take place. Here, if we have taken up one example of lithium, lithium will give up one electron and form 1s2 with 58 picometer. Magnesium is given Mg2 plus 2 electron with 72 picometer. So this is the ionic radii, which is important and it will come in paper. So you can do it. So students, after that we will start a effective nuclear charge. So in this one, what will happen? As the atomic size increase with increase in the atomic number, effective nuclear charge per electron is reduced and the electron cloud is held less tightly by the nucleus. Means in the nucleus they are less tightly, not more tightly. This cause increase in the size of the ion. When there is a less tight, then what will happen? The cause increase the size of the ion. The size of the ion will increase. We have taken a table 4.14, that is the covalent and the ionic radii have given chlorine, bromine, iodine, oxygen and nitrogen. Positive also and negative also, both the things they have taken, the values also be there. After that, variation of ionic radii in a group. What will happen? The ionic radii in a particular group increase in moving from top to bottom. As they are moving from top to bottom, means from the up to down, so the group will increase. In table 4.15, lithium having a 58 picometer, sodium having a 102 picometer, potassium 138 picometer, rubidium 149 picometer, cesium is 170 picometer. After that, we have started the variation of size in an. So here we have taken variation of size is an isoelectronic series. What is the isoelectronic series ions? These are those ions of different element which have same number of electrons. In this one, different elements are present but with the same number of electrons but differ from one another. Electrons are same but some properties are that type which are different to each other. That's why they are saying same number of electrons but differ from one another in magnitude of the nuclear charge. A set of species having the same number of electrons is known as isoelectronic series. Okay. What will happen after this? One such type of series shown below. This shown below is that N3 given plus 7, O2 minus give plus 8, fluorine plus 9, sodium 11, magnesium 12 and aluminium 13. So till here you will write down in your copy and next we will start. So my dear students, next we start the ionization enthalpy. What is ionization enthalpy? Let's we discuss here. Very important topic this is. The electrons in an atom are attracted by the positive charge nucleus. Electrons are attracted with the nucleus. To remove an electron from an atom, when we have to remove the electron, they want an energy. When they will give the energy, the electrons will go slowly from the atoms. The quantitative measure of the tendency of an atom to lose an electron is given by ionization enthalpy. It represents the energy required to remove an electron from isolated gaseous atom on its ground state. So in ionization enthalpy, there is a first ionization enthalpy which is said to be IE1. Is the energy required to remove the loosely electron? Means the loose electron, first of all it will remove that one. When it loses the electron, the neutral atom, and the second ionization enthalpy IE2 is the energy required to remove the second electron from the cation. Like A gives A plus E electron. So unit is expressed as kilojoules mole inverse. Second enthalpy as the energy required or enthalpy change to remove the second most loosely bound electron. Like A positive gives A2 positive plus E electron. So it will come as a positive sign here. Okay. After this, a very important note, this is the smaller the value of the ionization enthalpy, the easier it is to remove the electron from the cation. Means is this, if the value of the ionization is smaller, then it is very easy to remove the electron from an atom. The factors are, first is the size of the atom. In a size of the atom, in a small way I am going to tell you, like it become easier to remove the electron. When the size of the atom is small, it is easy to remove, and ionization enthalpy decrease with increase in atomic size. As the atomic size increase, ionization enthalpy decrease. Second is charge on the nucleus. As the nuclear charge is increased, then ionization enthalpy is also increased. Third is screening effect. Screening effect is also said to be shielding effect, which is very important. Okay, so in this one what will happen? In multi-electron atoms, the outermost electrons are shielded or screened from the nucleus by the inner electron. This is known as the shielding or screening effect. Okay, its formula is total nuclear charge. Its formula is total nuclear charge, that is Z, minus screening constant S. Next is penetration effect of electrons. In a penetration effect of electrons, it is said to be the multi-electron atoms, the electron in the s orbital, p, d and f orbital. Okay, as the s orbital have the maximum probability, then the found near the nucleus. If they having the more probability, they will be near to it. In other words, we can say s electrons are more penetrating towards the nucleus rather than the p, d and f. So this is the penetration effect of electrons. There are factors: size of the atom, charge on the nucleus, screening effect and penetration effect of the electrons. So screening effect having the two things, that is the total nuclear charge minus screening constant. Next property we will do now. So our next point is in ionization enthalpy, that is the electronic arrangement. So in this one, what do you want to say? It is depend upon the electronic configuration of the atoms. Electronic configuration, you know, 1s2, 2s2, 2p3. In this one, it has been observed that certain electronic configuration are more stable than others. Where means some are more stable, some are less stable because of half-filled and full-filled electrons. Half-filled or full-filled means half-filled means half they are filled. Completely filled means octet or shells are fulfilled. What are the consequences and the examples of it? First is the noble gas have the most stable electronic configuration, that is ns2 and np6 in each period. The elements like beryllium having 1s2 and 2s2, whereas magnesium 1s2, 2s2, 2p6 and 3s2 have two completely filled orbitals. The elements like nitrogen 1s2, 2s2, 2p1, 2py1, 2pz1 and phosphorus having 1s2, 2s2, 2p6, 3s2, 3px1, 3py1, 3pz1 have the configurations in which the orbitals of same subshell are exactly half filled and all stable. So overall we want to say the more stable the electronic configuration, the greater is the electronic. The more stable is the electronic configuration, the greater is the ionization enthalpy. These things beta you have to write down in your copies, and this is very important, which is coming in the paper. Okay, ionization enthalpies are there with the size of it and the ionic radii. Next we will start the atomic radii and other things, and the factors are also very important. Okay, so what the things which we have given, please write down in your copy. Thank you students and have a nice day.